Hey, welcome back, and in this video I thought I'd take a little bit of time to explore the new proposal that Microsoft has put forward to support type syntax within JavaScript. And if you're not aware of that proposal already, don't worry about it because it's only like 10 days old. In fact, they've not even submitted it as a Stage 0 proposal yet to TC39, which is the group responsible for maintaining JavaScript as a standard. But I believe they're doing that within the next month or something like that. So for such an early proposal, why are we looking at it? Well, to be honest, it's generating a lot of noise. So I thought it might be worth exploring the pros and cons and just making sure everybody's up to date with what that proposal is. Alrighty, so the first thing we'll do is let's bring up the actual blog posting about the new proposal, and then we'll sort of get underneath the hood of what it actually means. So if we look here, if you go to devblogs.microsoft.com/TypeScript, a proposal for type syntax in JavaScript, then there's a blog posting all about the proposal that Microsoft's put forward. Okay, so if we look at the blog posting, you can see what they want to do is bring an optional and erasable type syntax to JavaScript. So let's be clear. When they say they want to bring a type syntax to JavaScript, they want to bring TypeScript's type syntax to JavaScript, or a subset of it at least. And the idea of that is if you're going to write TypeScript code, then what they're sort of ultimately trying to say is that then I don't need to do TypeScript compiling and have this transpilation stage in between, and I would be able to run my TypeScript code directly in a browser or directly in something like Node.js. That is really the intention there. Now, if you haven't used TypeScript before, I'll give you a very, very quick demo on what that specifically means, and then we'll come back to what it means by the optionality. So what I'm going to do now is we're very, very quickly going to create a little Node.js project, and then we'll show what that means. So as you can see here, I've got a completely empty folder. So what we'll quickly do is we'll just bring up Visual Studio Code, and we'll create a very, very quick JavaScript file. So I'll create something called index.js, and then what we'll do is we'll create a very quick function that will just add a couple of things together. So we'll say function, and we'll call add A and B, and then what we will do is return A plus B. Okay, and then what we will then do is console log that out. So we'll do console log add, and we'll put 25 and 30, and then we'll just save that. And now if I come back to my terminal, then if I type in node index.js, you can see it has added the two numbers together. So I passed 25 and 30, and then it's added that together. So that is a very simple JavaScript addition function. Now, if I wanted to do something crazy, so let's say I, rather than want to add 25 to 30, if I just put that in quotes, so 25 is now a string, what you're going to see is the result is going to be slightly different. So if I do node-index.js, you see what it's done is a concatenation instead. So rather than adding the two numbers together, it's taken the 25 and put the 30 on, and basically it's concatenated it as a string. Okay, so now that we understand how that works, let's create the equivalent code, but this time in TypeScript. So what I will do here is click on New File, and I will call my new file calculator. And this time it's going to be of type TS rather than JS. So TS stands for TypeScript. And if I open that, you can kind of see on the left-hand side, it's got the sort of TS icon on Visual Studio Code rather than JS as I had before. Okay, so I've got my file calculator. And by the way, I've got TypeScript pre-installed on my machine, so you would need to do that before you did this example on your own machine. So what I will now do is I'll create my function, which is going to add these two numbers together. So just as before, I would call my function, and just as before, I would give it the name add. And what I'm going to do is pass in two parameters, A and B, as I did the last time. But this time I'm going to have to give it types. I'm going to have to declare what the types are in advance. So as you remember, I'm adding two numbers together, so the types would be of type number. So rather than type in AB like I had when I was writing my JavaScript, what I would do is type in A:number. So I'm basically saying that parameter A is going to be of type number, and parameter B is going to be of type number. And that's really the major difference here, right? Is with TypeScript, I have to say what my types are. Now, if I want to add the two numbers together, I would just type in return A plus B, as I did before. And then to log that out to the console, then I would just do console.log, and then I would put add, and then I pass the two numbers I want to add together. So in this case, I'll add 10 and 20, and then we can just save that. So there is a big difference, however, and that difference is I can't run those TypeScript files directly. So if I typed in node calculator.ts, I'm going to get an error. And you can see this unexpected token, blah, blah, blah. And that's because the JavaScript engine understands nothing about this type syntax. So if I just clear that, and what I would need to do instead is I would need to transpile the TypeScript that I wrote to JavaScript. And how I can do that is I can use the TypeScript compiler, which is called TSC, which I've got installed on my machine. And then all I would need to do is type in the name of the file. And so if I type in tsc calculator.ts, and if I just run that for a second, it'll take a few seconds, and you can see it has now generated a JavaScript file called calculator.js. So if I now run that and type node calculator.js, you can see my code is now working. So it's added 10 with 20, and it came back with 30. So if I come back into Visual Studio Code for a second, you can see it's got the output that I would expect, but I've had to have this additional step of transpiling this calculator TS to calculator.js. And if you look at the code here, then it's pretty much equivalent, right? It's function add A and B, return A plus B, and then log it out. So essentially, in order to make this code compliant for JavaScript, what the TypeScript compiler has done is it's essentially dropped the types. It's dropped the number types that we've got, and that's essentially what it's doing. Okay, so now that we understand what TypeScript is doing underneath the hood and how it transpiles from TypeScript to JavaScript, what advantage is that giving us as developers? Well, that main advantage that we are getting is we have the ability to have our types checked at compile time as we're writing our code for any errors, rather than it occurring necessarily at runtime. Okay, so let me show you what I actually mean. So let's come back into the calculator.ts, the TypeScript file that we created. So as you can see there, I specified the add function A and B as type numbers. And then what I'm doing is I'm adding the number 10 to the number 20. So what happens if I pass something other than a number? So rather than doing 10 plus 20, what I could do is pass in a string like I did before. So what am I getting? Well, actually, I'm getting these red squigglies underneath there, right? And then it's coming up with argument of type string is not assignable to parameter of type number. So essentially what it's saying here is, hey, you told me that you were going to pass in a number, right, for A, but here you are passing in a string. And what it's going to do is syntax highlight within Visual Studio Code to tell me there's some sort of error. But not only that, if I save this and come back to the terminal and then try and compile my TypeScript again, you're going to see that it comes back with an error. So you can see there's an error that says argument of type string is not assignable to the parameter of type number. The exact same error that we had coming up in our Visual Studio Code editor. So why is that important? Well, it means that I'm getting that static type checking capability at compile time. So these types of errors where I'm passing in the wrong types or I'm doing something wrong gets picked up early on and part of that compilation process rather than at runtime. So it's going to make my code better, it's going to improve, and I'm going to have a better developer experience. So that's the real thing there. And I'm not going to get into this situation where the code is going to do something that I'm not expecting at runtime, such as concatenating two numbers together as opposed to adding them. And for comparison's sake, if we go back into the original index.js file that we created, you can see there is no red compilation errors going on. There's no errors within Visual Studio Code. There's no indication that I'm trying to do two different things with types, because underneath the hood, JavaScript is saying, actually, I'm just going to do concatenation here, right? Because it's not stopping you or preventing you from doing reassignments and switching between various types. That's perfectly allowable within JavaScript. Whereas TypeScript is saying, no, you can't mix and match your types like that, and therefore it's going to give an error. So it's going to improve your code, right? It's going to allow you to find things at development and compile time, as opposed to finding these things out at runtime and having different consequences than you may be expecting. And again, if you look underneath the hood there as well, even though I'm not using TypeScript, I do have that hover capability. You can kind of see there, function add of type any, b is of type any. So in TypeScript land, it's basically saying I don't know what the type is. So there is sort of some sort of IntelliSense over the top of that. And again, if I wanted to replicate what I've got in JavaScript but in TypeScript, I could go back into my calculator TS, but rather than saying it's of type number, then I could say it's of type any. And if I change that to any and then save that, that error that I had before, yeah, is going to go away. So it's perfectly valid for me to then do a concatenation of 10 and 20 because it doesn't know the types. And again, if I hover over the add, then that's going to be the equivalent of what I had in JavaScript. So if I then saved that and then did my TypeScript compilation, you're going to see that it's going to work fine. And then if I do node calculator .js, just like I did before, then it's going to concatenate those two numbers together, so 10 plus 20. So you can see the TypeScript can work with types that you don't know, but you're going to get into a better state if you're going to be specific about your types, and then you can make use of the code syntax highlight and then the compilation checks. So now that we understand how TypeScript works and how TypeScript to JavaScript transpilation works, let's really look back at the text in that blog posting on how the new type syntax would work within JavaScript. So let's reread that first sentence there where it says, we're going to bring an optional and erasable type syntax to JavaScript. Now, as I said before, when it says bring a type syntax to JavaScript, what it means is it's going to bring TypeScript to JavaScript. And what it's then saying is this new syntax wouldn't change how surrounding code runs. It would effectively act as comments. Yep. And again, if we go a little bit further down here, it says a recent trend our team has seen in the JavaScript world is a demand for faster iteration time and a reduction of build steps. In other words, make it faster, make it simpler. And so what they're saying is, thanks to the success of Evergreen browsers, developers can often avoid compiling new versions of JavaScript to run on older runtimes. We'll challenge that a little bit later on. To some extent, the same is also true of bundling. Most browsers have a built-in support, blah, 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 blah. So if we look at that, I'm going to skip all of this just now, but essentially what they are saying is, what if we could have something like TypeScript syntax which was totally ignored, sort of like comments in JavaScript? So therefore, what they are saying, if you look at this example, function add a number b number, which is what we wrote earlier, what they are saying is rather than having to do that transpilation, where we took our function add a number b number and then turned it into function add a b, then what you could do is just write the TypeScript code as you would do before and keep the types. And then when you ran the code either in the browser on the back end for Node.js, then the code would run. That is essentially what's happening. So rather than in your JavaScript, you could optionally add in number like that, and you wouldn't get any errors. You wouldn't get any squiggles. You wouldn't get anything saying type annotations can only be used in TypeScript, as you see there, right? It would work, and it would work within the browser, and essentially the JavaScript engine would ignore it. But as you saw earlier, if I save this, so I've got the calculator.js file. If I then came back into Node.js and typed in node calculator.js, you can see I'm getting an error, which is unexpected token. Because JavaScript engines, whether it's in the browser or whether it's in the backend, such as Node.js, will not ignore types as it stands today, and it will throw up an error, i.e. the unexpected token. But the proposal is to say, well, JavaScript engine, if you see that, just ignore it and then run it as if it wasn't there. Treat it as a comment. And what's the advantages of that? Well, the advantages, according to the article, is supposedly because of Evergreen browsers, then I don't need to do that transpilation step, and therefore I can just write my code with my type syntax, not do that transpilation, and then it will work. And why that's important to me as a developer is because I'm going to get all of that syntax highlighting. I'm going to get those errors coming up when I do something like passing strings into numbers. So when they say treat it like a comment, what exactly are they meaning by that? Well, let's come back into Visual Studio Code for a second. So what I'm going to do here is I'm going to get rid of this calculator.js file. We'll just delete that completely. And then what we're going to do here is we're going to rename this calculator ts to .js. So it's back to being a JavaScript file. And what we'll do is we'll get rid of number from here. So it's back to the way it was before. And what we're going to do is we're going to make use of the JSDoc syntax, which gives us the equivalent of TypeScript and have the ability to sort of see your types and have checks within Visual Studio Code. So let me show you what that means. So to do that, I would do /* to give myself a comment. And then as soon as I do that, you can see it is automatically came up with these param and returns. So if I then change that star, so rather than it saying star, if I put number here, and then I put number here, and then save that. And then if I do that hover over here, the add is now saying A number, B number. And now if I put that back to star again, let's just put that back to star and hover over the add, you can see A is any and B is any, right? So I've got that equivalent of syntax highlighting within Visual Studio from the use of comments, and that's what they mean by the proposal, right? You know, when they say treat it as if comments, it is essentially saying behave as if you're using the JSDoc format. But really what they're trying to say is I don't want to be typing in the JSDoc format. I don't want to be doing anything funny like that. All I want to be able to do is have my type syntax as a number, but then treat it like you're currently treating JSDoc. And that's what they're specifically meaning in that proposal. And then I do get some advantages of that. So if I then pass in 10 like that and then hit save, you know, it's not going to come back with an error because it's still valid in JavaScript land. So if I do a node calculator .js, it's still going to do that concatenation. It's not going to stop me from doing anything because I don't have that compilation step. But at least I've got the I've got an idea of what is expected. And if I type in there add, you can see it's telling me I expect a number. However, with that being said, you know, as it stands today in JavaScript, if I want to enforce some sort of type checking, then what I can do is add // at ts check at the top of my file and then hit save, and then you can see, look, Visual Studio Code is now kicking back in with squigglies, and I'm getting the argument of type string is not assignable to the parameter of type number. So that is something I can get the equivalent of what I wanted in TypeScript within Visual Studio Code by using the JSDoc format to specify what the intention of these parameters are, and then by putting the ts check at the top there, then I'm going to do that background compilation with TypeScript with my TypeScript compiler, and then get the same errors as I would have from the TypeScript compiler within my code editor. So you don't necessarily need to have your type in there to be able to support that. You could use that using comments, but as per the art, and that's really what they're meaning in the blog post and when they say treat it like you're treating comments. But what they're saying is actually that's too much of a pain for developers. It is actually easier just to go a number, b number, rather than and doing that as TypeScript, you know, rather than put in all of those comments in there. And of course, because this is a JS file rather than a TS file, it's coming back with squigglies there, and it says type annotations can only be used in TypeScript. And of course, even with the TypeScript compiler, I could do some sort of type checking today. So if I come back into the terminal, let's just clear that for a second. And if I type in tsc calculator.js and then say create me a new out file, and I'm going to call it calculator out.js. And then what I'm going to do is ask it to check the JavaScript, so check JS there, and then it'll run for a second there, and then it's going to come back with an error. So I do have some type checking capabilities within JavaScript files by using the TypeScript compiler, but as you can kind of see there, I'm going to have to mess around with comments, and then I'm going to have to put that compilation step in there. Coming back to the proposal, is what they're saying in the proposal is, let's skip all of that, yeah, rather than having to use the JSDoc format, let's just have the colon number or colon type so that I can just pass my types in, and then the JavaScript engine can ignore it, and therefore JavaScript is going to have static types as everybody is wanting, supposedly. So what do we think? Do we think this is a good thing? Do we think having type syntax within JavaScript is a good thing? Do we think that treating it like a comment like you would do with JSDocs is a good thing? Well, I'm in two minds, and I'll tell you why I'm in two minds, right? Because my number one is like, well, actually, that could be quite useful, right? Rather than having that transpilation step, especially for backend, right? So if I'm writing something in Node.js, being able to just include the type there, yeah, that makes kind of sense. Not having to do that TypeScript compilation step. I kind of like that idea. And actually, if we were to look at, and this is one of the arguments in the proposal, is that if we were to look at 2020 and 2021 State of JS report, then it is the most requested feature, right? So static typing is the most requested feature in the survey by JavaScript developers, right? So developers are saying, you know what, I do want that static typing capability. Now, not everybody's going to use it, which comes back to the point of it being optional, so you can choose not to use that. But then I do worry, right? When we say things are optional and then we start baking that in, is it going to be truly optional or not, right? Who knows? But I like the idea that I could write my TypeScript, I could have my types within there, and then I can maybe skip out that TypeScript compilation step. So I think yeah, that could be a good thing, right? Do they have a point about JSDoc? And I have to say, yeah, it's a little bit of a pain typing that in, having your comments there, especially when you get to the browser, because you're going to do things like minifying, you're going to want to try and get rid of your comments, etc. So, yeah, you know what? Does that really work within the browser land? Probably not. So I sort of get their point that actually, having that built into the language would be good. The optional part, I worry about for the browsers for a second, because if it's optional, what stops me just using Babel or a compiler to get rid of it anyway? So because I'm going to be like, I'm going to get rid of these types and spaces. So I don't know, maybe that's not a good thing. But certainly back-end side of things, I can see that being useful. So in some regards, I could be pro on that, but I can understand why people are negative, and there is a lot of people negative on things, right? So there's certain comments that are coming up which is, I don't want this, what about this, what about why, how is it going to handle this, what if I put in a load of garbage, what issues is that going to come up? People are worried about performance, and we'll cover that one in a second. I guess the thing that I'm probably going to challenge, though, and I'm going to challenge this from a browser perspective, is the idea in the proposal about evergreen browsers having become the norm. And let me just sort of bring that back up for a second, right? And I struggle with this. So what they're saying there is, thanks to the success of evergreen browsers, developers can often avoid compiling new versions of JavaScript to run on older runtimes. And I just don't buy that. I don't buy it at all. And I get the fact that maybe they're saying, I'm going to invest for 5 years, 10 years in the future, so that eventually when everybody catches up with browsers and having, TypeScript types within JavaScript in that period of time, then at that point I might be able to skip that transpilation step. But the idea that, you could just implement that today, and therefore, because everybody's running evergreen browsers, then you can start using that feature, is just nonsense, in my opinion. Invest in the future, sure, but the fact that you could just use that today or tomorrow when they implement it, because you're going to automatically upgrade all the browsers, that's just nonsense. And let me prove what I mean by that for a second. So what I'm going to do is I'm going to bring up the browser market share for all browsers across worldwide. So, if you haven't seen this before, go to something like JSDoc counter. You can just Google this, and then it will tell you what percentage of browsers are on what. So you can kind of see 62% of browsers are on Chrome, 90% on Safari, 4.2% on Firefox, 4% are on Edge, 2.7 is on Samsung Internet, and 2.2 is on Opera. But actually, I can go even deeper, and I can go and bring up browser market share by version, and that becomes super interesting. So if we have a look at this, then what it will do is tell you the market share by each individual browser version. So if we look at the table version of these stats, there's some things that we can pull out there, which is Chrome for Android 34%, Safari iPhone 14%. So no sense, I'm with that. They are evergreen, right? So if you're running Chrome and Safari on your iPhone or Android, that's evergreen. You're going to get the kind of the latest version there. But let's start looking at Chrome on desktop, right? And that's where it starts to get interesting. Chrome 91, 96, 89, 88. But so let's kind of scroll across there. So even there, you can see there's a ton of different versions. Okay, it's small numbers, but there's still people on the older versions, right? And in fact, if we look here, Chrome 97 is running 7%, and then that is in the current month. In the previous months, it was 15%. So you can see 7.5%, of total browsers worldwide. They've shifted fairly quickly, off of Chrome 97, and as you would expect, onto 98. So on Chrome 98. There was nobody on that, and then suddenly it was at 15%. So you can sort of say the previous two versions, so Chrome 98 and 97 make up sort of 22% or 22.5% of all browsers in the world. But it's taken a couple of months to do that. If I go further across here a second, I can see a similar story happening both on Edge and on Firefox. So if I look at Firefox here, as new versions of Firefox come out, Firefox is on 2.57. You can see on Firefox 94, it was at 2.57 a couple of months ago, and then it goes to 1%, and then all the way down to 0.05. And then if I look at Firefox 95, you can see a similar story as the new version comes out. So as each new version comes out, they're switching across. So it gives that sort of evergreen browser story. But I still have older versions kicking around. You can see Firefox 86 there. I can see Firefox 85. Okay, that's went down to 0, but it's taken a bit of time. And then in fact, if I go as far back as Firefox 52, you can say 0.06% of the entire internet population is on Firefox 52, which is years and years and years old. So I honestly get what the proposal's trying to say, and I really do, right? Which is, you know what? As time has gone by, we've got evergreen browsers. That means that the older browsers, the IE6s, the IE8s, IE9s, and are all gone from the world, and therefore, because we're on these evergreen browsers, then we can introduce a new feature, and therefore everybody will get that feature within a couple of months. But as the reality is showing here, right, and you can see it in the statistics, it's not like everybody is getting it straight away, right? Sure, on your iPhone, on Android devices, on the later Chrome devices, etc., the vast majority of people are getting the latest updates, are getting the latest versions. I get that. But it's taken years and years and years before those browsers are being updated. And a perfect example of that is if we look at something like ECMAscript 2015, right? The fact is that there is still a percentage of browsers that are not supporting that, and it's taken years to the point where it's a sort of vast majority. And even with that being the case, it still means that most people are still transpiling for older browsers and not using the native ES 2015 features such as import statements, etc., directly with code, and they're actually transpiling down to commonjs. So if we haven't achieved that, and I think we should be able to achieve that soon, if we haven't achieved that yet in a sort of 5, 6, 7 year period, then why do we think that it's going to be any quicker for us to have the same equivalence for JavaScript features? And the answer is it's not. It's going to take years before everybody gets to a version of a browser that's going to support that version, because people don't update their browsers that often. Certain places they do, but not everyone. And the stats still show that today. You can still see 0.4% of the world is on IE 11. You can argue that maybe they shouldn't be on IE 11, but they are, and that is a reality. Now, the second thing that I want to bring in here is this is a very Western view of the world. So at the moment we're looking at the worldwide stats, but let's take a second and have a look at the version stats for Africa. Alrighty, so I brought up the exact same stats for browser versions, but this time rather than looking at the worldwide stats, what we're going to do is look at the stats for Africa. So similar, you've got Chrome for Android, Safari iPhone, Chrome 96, etc. And you can kind of see that the Chrome for Android and Safari on iPhone are sort of dominating the stats, and it sort of makes up 50% of all browser usage, right? And then similar, the latest versions of Chrome is the one that's going to be updated. But there are some more interesting stats as well. So if I just scroll across here, you know, you can see Firefox is used much more often in Africa. And again, it's sort of latest version. So 11% is on Firefox 97. And you can see that transition from Firefox 95 goes down, and then moves across to Firefox 97. So that's great. And it sort of supports that evergreen kind of theory. And you see the same with Chrome here. There's Chrome 97. It's at 7% down to 2%. So you see that shift to the later versions of Chrome. But let's scroll across here. Look here, 0.35% of all browsers in Africa are using Opera 58, right? Not Opera 78 or whatever, Opera 58. That's a browser that's years and years old, right? And it's not the only example as well. So if we come here, you can see 0.5% is of all browsers in Africa are using Chrome 56. If we scroll across there's Opera 61, which is 0.64%. And again, Opera is a really popular browser in Africa, right? So it's just something to kind of be aware of there. 0.1% is on Safari 14. And then if we go even further, we can see things like Safari 5, Safari 2, and then we've got some browsers. I'm not actually sure about this browser here, Instabridge. I don't know what how evergreen that is, but it looks like a new browser that's. I need to check it out at some point. It's got 0.82%, so nearly 1% of browsers that's in Africa. There's Opera 62 at 0.5% of usage. So hopefully you get my point from the African statistics that although a lot of people are on the evergreen browsers, there is a huge estate of browsers. If we suddenly start transpiling our web pages to include types, their browsers are just going to break, because you know what? They haven't upgraded their JavaScript version, their browser versions in something like 3 years. Now, of course, in 3 to 5 years time or whatever, then the vast majority of people will be on the latest version. But until then, the idea that you can just update the browser engine version, JavaScript, to ignore those types, and you're not going to break the web is ridiculous. Yes, it will happen over time. But if you look at the stats, both in what we're seeing today and what we're seeing in regions such as Africa, then it's going to take years. It's going to take at least 3 years. It probably might take as long as 5 years before it's a number where it's small enough where it's not going to make too much of a dent. But even then, think of the people that have those low-end devices, and that's the real key thing. It's usually those browsers are on low-end devices, right? So what you're basically saying at that point, no, you know what? You're going to have to get a newer machine to be able to access that code. And if you don't think that's a problem, Well, look at Windows XP or look at Windows Vista, right? There's long-term support versions of Firefox, there's long-term support versions of Chrome, but you can't get the latest version of Chrome, you can't get the latest version of Firefox on XP or on Vista. Now you might be saying, well, they are no longer supported operating systems, so that's fine, and that's okay. But then if you're somebody who has a Vista machine or you have an XP machine and you can't afford another machine and you're locked to that browser, you are basically turning around and saying, you know what, I'm going to stop you accessing the internet because JavaScript is going to stop working. So I get what we're saying. I get the fact that we want to cut out that transpilation step. We want to have those latest JavaScript features. But actually what we're doing is hitting the people that it hits the worst and saying you have to update your browser for people who really may not be able to afford or get the latest version, and we're going to be cutting off internet access. And I think we have to be a little bit more responsible in that. And that's why we are still transpiling to CommonJS even today, even though it's 5-6 years on since browsers started having support for, in fact, it's probably 6 to 7 years, right? Having support for things like the import statement. But in order to have massive inclusivity, right, within browsers, we are still supporting those older browser versions. And of course, in time, as people stop using that, in the same way as people no longer use Netscape or NCSA Mosaic, where we're no longer supporting that, right, there is a time period where we can move along. And I get the point about evergreen browsers, but the idea that you're going to be not transpiling if you introduce that feature and have JavaScript ignore that anytime soon, I think is ridiculous. So I think from a proposal perspective, I get the intention, and if you look at it in a future facing state where you say if we bake this in now, then in 5 years time or in 10 years time, then you might be able to not transpile for those cases, that makes complete sense. But the idea that you're going to be able to do that anytime soon, I just find ridiculous as a concept, and you know, feel free to argue with me in that, and I accept it, but the data is right in front of you and you can go and check it out for yourself. And by the way, I love the passion for this, and I love the idea that we can stop supporting things like CommonJS and we can use latest ECMAscript standards, and I love the passion for this, but honestly, if Microsoft genuinely believes that we don't need to transpile, then you know what, Microsoft, then stop transpiling yourself. And if I go to Microsoft.com and if I open up View Developer Tools, and then if we, let's go up to Network for a second, let's do a refresh. And then if I pick one of these files, let's pick Social API version. Let's scroll it out there, and look here, we can see object defined property ES module. What does that mean? It means they're using TypeScript underneath there. Great, well done. We love the fact that you're using TypeScript. But guess what you're transpiling to? You're transpiling to CommonJS. You're not transpiling to ES 2015, right? That is something that the TypeScript compiler uses. So you are transpiling to CommonJS yourself, and you're not using the latest features that come as part of ES 2015 in your own website. So I get the passion, but you knowing yourself that not enough browsers and to have massive inclusivity, you need to compile to those older versions for support across the entire world. And I get that is not the case for everyone. I get there are certain scenarios, there's certain places where you wouldn't need to do that. So maybe if you're building stuff for an internal site and you've got control of the versions, or maybe if you're in a market where you know the people who are accessing your site rather than necessarily looking at you know, worldwide browser statistics. If you have built up stats of your websites and you know exactly who's accessing it, and you can say, you know what, people on older browsers aren't accessing my site, and therefore, do you know what, it makes sense to use the newer features and stop transpiling down, then that is a good thing. But there is still a population that is going to be using older browsers, and it will take them time to upgrade their browsers as the years go by. And therefore, the idea that you're not going to have that build step for certain things is naive. Now, as I said, there's going to be a set of people where you are going to be able to do that, and that's fantastic, and that's great. And you know what, you should lean into that. But before you make those decisions, you really need to understand who your audience is and who's accessing your site, and keep inclusivity as a key part of that. So anyway, as you can probably gather there, I do think it's a good thing. I just think that it's just a little bit naive thinking that you're going to be able to use it straight away. There are some other things that people are sort of maybe complaining a little bit about. So one of them is people are worried about its performance and saying, well, actually, you know, if you're going to have to handle types when the code comes down, is that going to have an effect on your performance? And the reality is yes, but probably minimal, because the JavaScript engine has to work out your types anyway, because underneath that, if we look at something like the V8 engine, then that's implemented as a register machine, and therefore you have to know what the types is in order to compile down to the assembly type language that's implemented in the V8 engine. So therefore, what's the hit? It's probably very small, because it's going to have to figure it out anyway. In fact, you're probably going to make its life a little bit easier, because then rather than having to figure it out from the tree, then you're being a little bit more explicit about what the types are. So, you know, is it going to have an effect on performance? Maybe, maybe not. Are you pushing too far into being a static language? Maybe. I guess if you really want to be a static language, then you can, you know, lean into something like WebAssembly a bit more, or AssemblyScript in that case is another example. I guess that's a path I think we're going to end up going further down in the web world anyway. I think WebAssembly is going to be a bigger thing over the years. But I do think types is going to be a good thing. Yes, there might be some impact for things like performance, but I think it's going to be minimal anyway, and it may end up improving things. Yes, there's going to be a whole set of things of, is that the direction you want the language to go in? I don't think it's a bad thing. I quite like the proposal, as I said. People do seem to want it, but then there are people who don't want it. And, well, quite frankly, if you don't want it, then it's optional, so, you know, don't use it. But it's maybe not a real argument, because kind of like TypeScript is the more other people around you use types, then you're kind of forced into it yourself. But it is going to bring benefits, right? Because it's going to be easier to do things like generate API clients, etc. And you can use the same sort of tools you have with TypeScript. It's going to help you create better code. I think it's a good thing. I understand completely why people may or may not like it, and I understand the reasoning. But, you know, let's see what happens over time. To be honest, I sort of agree with the general community when people are saying it's not going to remove that build step. As I said, and as I've proven in this video, I don't think that build step is going away anytime soon. So, you know, I don't sort of believe in that argument, but still I think it's probably a good thing. Anyway, I hope this video has been useful, and I'll catch you on the next one. Speak soon.